Hey everyone, today I want to try and teach most of the concepts needed to learn perspective using this door. So basically we're gonna cover everything from vanishing points and horizon line, multiple vanishing points like division, proportions and transfers, ellipses, and cylinders, and the beginning of volumes. We're not gonna be going very deep on that. Other resources important and interesting for you all to see: Scott Robertson's book, How to Draw, or Marcos Matteo Mestri's book, Frame Perspective 1. Both I've done reviews here on the channel, so you should definitely check that out. Let's jump right in and look at vanishing points and horizon line. So these are the most basic concepts you see in perspective. So every line that is parallel in the real world, in the non-perspective world, will converge to a point in the vanishing point. That's the basic principle. Marshall Vandruff has a great video on that. I'll try and find the link and put it in the description below as well, talking about convergency and giving the sense of three-dimensionality and perspective and how to convey that things are far away and not on the paper plane. So yeah, parallel lines then will converge. So the top of the door frame as well as the bottom of the door frame will converge to the same vanishing point, as well as the lines from this wall back here, they will converge to the same vanishing point because all that lines that are on the wall are parallel to each other. This, I'm assuming from what I'm seeing in this perspective, that this door frame is perpendicular to the wall back there. So from a top view, we would have the door frame here and the wall back there, and then the door like coming out this way. So we're seeing this wall from this side. That said, it will be a 2-point kind of situation. And how can we test that? If the verticals from our scene are perpendicular, so they have a 90-degree angle to the horizon line, then we are in a 2-point situation and not a 3-point. If we're looking upwards, we'll have a convergence to the top. If we're and then the eye level will be different from the horizon line, and if we're looking down, we'll have a convergence down, and then the same will happen. The horizon line will go up in this case. In the case that we're looking up, the horizon line will go down. But on this 2-point situation that we have right now, we have the eye level and being the horizon line as well. So we can find that just getting the parallel lines to converge to a single point. And that gives us as well, not exactly, but an idea of the cone of vision. So if the at least one of the points is out of the frame, the picture plane, then we have a situation where we're almost looking for like a 50mm lens, if this is a camera in this case, or if it's the like human eye, it's going to be around like this 50mm. So we might have one point here on the canvas, on the picture plane, but probably the other one will be out of the picture plane. If we have both in the same picture plane, it's going to be something like this. We're going to probably be talking about a fisheye situation. Then we're going to start to have more of a circular perspective. So something that looks like this, and everything, all boxes that we have are going to be starting to rotate in this perspective. As we can see with any like fisheye footage, as well as if we do have them even more apart from each other, then we're gonna have a situation where the picture plane is closer to the center of this, and then we're gonna have things that are way flatter because they are converging to points that are really far away. So it's going to be way harder to notice perspective. So that's basically what we think of when we talk about the cone of vision. And in this case, we also have multiple vanishing points. So it's not a situation, a one point situation that we're gonna have like the center of vision and something that is parallel to the picture plane or perpendicular to the eye of sight. If we think the eye of sight, the eyesight, the center of vision, the line of sight is here, then we would have this being perpendicular, this plane, and then we can even like draw the box around this in a 1 point situation. In a 2 point situation, as we said before, we're gonna have convergency here as well, so we can have the box once again going to the vanishing points and so on and so forth. This is basically what everyone has done, this exercise of drawing boxes in perspective in one way or another. But when you rotate 2 point perspective, so you have something that is 90 degrees and is as we just drawn, and we do rotate that in a different angle, the two vanishing points are going to change. So in this case, we only have one here, the door, and we're going to use that and extend both the bottom parts as well as the top parts of the door and find the vanishing point. So we understand that this is not a situation where the door is parallel to the wall behind it. It's more of an angle, and then this instead of going and converging to the same vanishing point as the wall, it will go a little closer to center line because it has rotated from this to kind of this position. The same will happen if it keeps rotating, and I've done two exercises here. So if the door goes to this point, and we have the rotation all the way, the door is going to be here. Or if we go even further to like this point, and we have the door almost closed, then we're going to have a situation where it's converging to this side, almost getting to a point where when the door is closed, we're going to have a situation where it's converging to the same vanishing point as the rest of the wall. So that basically covers like 90-degree angles, rotation. Auxiliary vanishing points, I'm not going to go into deep here, but if we did have like a door that is on the floor here, using like this same, let me use both vanishing points actually. I'm going to use this one for this side and here, as well as here, and then close that. So if this is like a rectangular door, you have a handle here, and it opens from the floor up. So maybe a staircase here going down, or something like that. This is way smaller than I wanted for this staircase to make sense, but you get the point. So if we do have the door opening in this direction, we're going to talk about ellipses. We're going to have ellipses helping out understand this movement on both sides, as well as this top part will go again all the way to the vanishing point. So I need to just correct this a bit, and then this will like have something like this. And auxiliary vanishing points in this case will be the vanishing point to which these two lines are converging. So this here is converging down, and also here converging down. And they will both converge to a point under this vanishing point, an auxiliary vanishing point that is under here. So if we did have a door way more closed, and we can come from this point all the way here and have the door here. We can get it to the other side and then back, and we would probably have like this situation where the door is closing. So of course the ellipses that I'm using are not very accurate, so it would have to go more on this direction, so a little closer to this, and then this one wouldn't converge as well, but we're gonna always have a little bit of distortion in perspective. I've seen a lot of examples, even from Scott Robertson or Feng Zhu, that lines don't converge as well, but the sense of three-dimensionality is there. So have that in mind, and don't ask too much of yourself on that sense, because you can definitely convey a lot of three-dimensionality without being 100% accurate with the perspective. So that's basically it. And 3-point perspective, we already talked a bit about that. Division, so that's an important point. We're going to talk first about the diagonals, or the X tool, as I like to call it. If we do have a rectangle, any rectangle, and we use the diagonals, we'll find both the vertical division, so this is equal to this, as well as the horizontal division. Oh, actually, this is more of the horizontal and this is the vertical, but you're using a horizontal line, so this equals to this as well. So the same will happen in perspective. So I'll just zoom right in a bit, and then we can see that and there is a little bit of a distortion here, in incorrectiveness. So this is going to be the center line of this symmetry between the details from the door. And this is going to be super important if we do want to transfer some of this. We're going to use the center line and duplicate that to the other side. So we can, for example, get a point like this, as we're doing, and almost it is touching that point. So we're going to almost assume that it is. If we get this point and throw that back to the perspective of the door, so be mindful of which perspective you're using for the convergency. On the other side, as we're using this line to the top, we're gonna find the other point. If we want to do like this point, we can do the same and duplicate that to the other side using the center line. So we can do something like this, get it to the top there. Get that point to converge, so we find the point on the other side of the door, and then get that down there back, and we can use the perspective as well here on this point, converging, and then a little bit of an imperfection in there, but then we're gonna find this other point duplicated to the other side. There are lots of methods of doing this. Scott Robertson's book is great on this, as well as frame perspective. So I definitely would encourage you guys to do this. Proportions and transferring, we're going to go a little deeper here. So if we do want to transfer proportions to the vertical line, as it's a 2-point perspective situation, we can go like straight away and just mark where we want those points to be. And if we do the same on the other side, it will match. So those points, they're gonna have the same proportion because it's on a vertical, a real vertical plane. So if we do get this on top of this one and make it smaller, it will fit perfectly. But if we're trying to transfer something to a line that is converging to perspective, then we definitely need some methods. And this one, for example, will get the proportions we want. So get all these small lines that will get the details in there. Instead of like duplicating, we can use it this way as well, or we can draw on the center line and just transfer. And use a reference vanishing point or a measuring vanishing point to help out get all those points across to the line that is converging in perspective. So if you have any doubts on that, please refer to the books. Both of them are amazing on that, especially frame perspective. One has a great discussion on that topic, and will definitely teach you better than I would. Also, now that we've seen division, we've seen vanishing point, reference point, and scale. So if we do have a door going in perspective, it's gonna be to scale. It's harder to transfer this measure to that point. You can do that by duplicating, as we said before. So we can have this and have like the midline. So I'm gonna use a different color here, and just get this point. It's almost on the horizon. So a little under the horizon there. So that, oh, sorry, my mistake. So that's midway. And then we can use this point to duplicate and get that across and up. And then we have the door on the other side. If it's a double door, we now have the other side. I'm gonna do get back to this pink color, so it's the other side, and we can keep duplicating that all the way across and see how that will translate. And if the door is in here and we have like I'm gonna change colors again to green. If we do have a door in here and in here, we do have this working in perspective, and the sizes are going to be the same. If we do have a figure like in closer to this door, I'm gonna like just do it this way. Then if we transfer all these points using the vanishing point, then the figure is gonna be in here. So we can use that as well to transfer all proportions. If we do have figures that are the same size in the real world, so we can the proportion between them and the horizon line, it's also gonna be the same. So if you're sitting down in this kind of scene, the observer is sitting down and almost like the closer to the chest line of the figures. If we did have like a chest line here or a belly button or something like that, we can think of some anatomy here. And then if we are sitting down, all figures will have the same proportion. If this, for example, was like a big door, and we had a figure that was the size of the horizon line, or just a child coming in, all children would going in the distance would have the same proportions, and their head will go to the horizon line. So you can populate the scene using the horizon line. So if you're drawing on the street and it's a crowded street or something like that, you can definitely use the horizon line to your advantage. Next, last but not least, to be honest, we're going to be talking about ellipses. It's a way harder topic. So please refer to the books. They have great construction. I love the approach by both of them. Scott Robertson, I learned a lot from him, especially from this square that goes around the ellipse, and you can find all the proportions and if the ellipse has the right degree, so how apart these points are. So it's very important to understand this construction. So if we do have a circle, and I'm just gonna stroke this 7. If we go tangent here and here and here, and I'm not going to be perfect tangent here, but almost there. So if we do get all the diagonals here and here, as well as like verticals, we can see this happening here. This is exactly what's happening here. So this line is one of these, and so on and so forth. And also the ones that are going to the vanishing points. So here is one of them, as well as this one, where the perspective and the ellipse is going to be touching. They need to be here as well, and the ellipse need to be touching this point in the center. So that's going to happen in all of them. If that's not happening, your ellipse is not accurate enough. So please be mindful of that. So this point in here, as well as this point in here. So that's basically it for the square construction, as well as construction. Minor axis always is going to be the center of the rotation or the perspective. If we do have an ellipse that is going like a car wheel that is going to this direction, this is going to be the minor axis of the ellipse. This is not a very good ellipse, but you can understand the point. It's the same here. The minor axis is going to be the center of rotation. So it's going to be the end of the door around which it's turning. So if we do get the proportions and rotation back, and let's just change color here pretty quick. We can use the ellipse now to have a very accurate door. So it will go up here to this point and meet the ellipse up there. So this is gonna be the door at this point. And if we do have that going in this direction, the same will happen here. And the door will be almost closed in this point. So that's basically the use of ellipses to understand rotation. If it's a book, if this was like laying down, all the pages of the book that are turning, maybe a windy situation where a lot of pages are starting to turn, you can use ellipses to understand the limits of all the pages. So you can have them in here, for example, just go down and use the ellipse again as the limit, as well as this side, and just go back to the center point. Okay, hope that makes sense. If not, the books are gonna be great. Perception has a great relationship with the horizon line. So what's the degree of the ellipse has a lot to do with how close to the horizon line it is. And also if we're seeing that downward or upward, it has all to do with the horizon line. So this one, we're gonna be seeing the bottom. So if we did have like a cylinder situation, let's think of like a pod where you have a door that you can go in. So this is like a cylinder, I don't know, time machine or something like that. You can go in and you will see or a telephone booth or something like that. You will see the bottom of this ellipse as well as you're gonna see the top of this one. Okay, and that's when you get closer to the horizon line, it will get closer and closer to a straight line. So the ellipse here is gonna be way flatter, and my drawing here is not gonna look good, but just so you can understand that it's going flatter. I used like the ellipse 2 here on Photoshop to get it right. One thing that I usually do is get the limits of the ellipse if I need to draw something. So if we're going to be drawing the whole cylinder here, I will do that, and then maybe just go with some dotted lines so I can just feel if that is right before I have the final line go over it. So I think this is more in this direction, and once it starts getting up, it will follow something like this all the way to get to that line in there. So it needs to keep changing. I think this middle one will get closer to this. So if we have, for example, this is a leg, and a leg will be more, will have more of a cylindrical shape. If we do have like stripes in a pair of pants or something like that, we can think of this being like this. So if the figure was here, and we do have a cylinder, let's do it a little bigger. We do have a cylinder here. It needs to respect the horizon line, and then it will start turning down. This is a different situation where when it's inclined, it depends on where the center of vision is going to be. But if it's perpendicular to the horizon line, it's going to be something like this. As well as the same on this side, it's going to be going down. If we do have stripes around this, in the ellipse going to the other side as well. And the degree of the ellipse will start to get smaller and smaller as it gets closer to the eye line and the horizon line. That's the same on this case. We can also use it for cutting and rounding shapes. So let me just get this smaller again. Cutting and rounding, and also the center line of that we're going to be cutting around. Another point for volume that I haven't discussed here today, that I think it's the last point I would say. And there's another one, just a quick one, a quick segue from the when we started to duplicate. If it's not this side, for example, instead of being like very straight, it was like this, more of a Gothic kind of angle, then we would have to figure out what that would look like on the other side. So this would be the center line, and then we'll need to figure out these angles and maybe transfer some of these points. And there are strategies to really transfer these points and what they look like in terms of the distance and for shortening and all of that, and what that would look like in this case. I think it's even a little closer to here, almost to the center of this, and then this line would go like this and all the way down after that. So this is basically duplicating arches. We're going to be discussing that in other videos down the line. But the volumes, when we're discussing, for example, a boat, and we do have something like this, and perspective is converging. And we have some cuts in here, for example, like this, and then like this. Everything needs to be symmetrical in perspective as well. So this is going to be a situation where the center line here in purple is going to be super important so that we can maintain symmetry, especially if it's the other way around, and we do have a volume that is going this way, and we'll have some cut lines here and there. For this part, the best book definitely is Scott Robertson's How to Draw. So we can have the volume in here. It's going to be something like this, and something like this. And then we can have this line that will go from here to here, or something like that. So this is super important. This is the only concept that I haven't covered with the door, because the door is flat, so we can't look at something that is going in the distance. So that's something to keep in mind. But other than that, the door has helped us to really cover everything that we need. So that's it from me. I hope you enjoyed the video. If you did, please like and subscribe to the channel. If you are already subscribed, thanks for coming back. And I'll definitely hope to see you all in another video. Have a great one.